So for that, I'm going for the router. I'm going to take a generic router. So let us place the generic router here. So we're going to connect some, let's say, 3 different types of networks for this. Right. Then we're going to take, there is something called, if you see at the down, there is something called central office server. We're going to take one central office server, which may connect to a network here, this side, or which will manage a network, a mobile network, the way we are using our mobile devices, the mobile network. We may also see how actually the mobile network will get connected to the internet and other things. Let's see. All right. So one, we're going to take some central office server for this example. Then we're going to take something as cell tower. Probably this cell tower is connected to the central office. From the central office, we are trying to route the packets. So that's the reason we're going to take one cell tower. So let's not worry what is the detailed configuration of cell tower, but probably we'll pull out the details only which we are required as of now to understand this topology. Then we're going to take a smartphone. Maybe we say the smartphone is get connected to the cell tower. Maybe by this time, okay, it's got by default, it got connected to the cell tower using a SSID, right? Default SSID or whatever this tower is trying to broadcast. Then I'm going to take 2 more servers, probably one server for maintaining a DNS, one server we're going to maintain the IoT components, IoT services completely. Right? So this probably we may use for the as a DNS server. This we may use for the, let's say, IoT device or IoT server or monitor server, whatever it is. So IoT server. And then we are going to take a WAN emulation. We're going to use a WAN emulation in this. Let me take one WAN emulation here. And this WAN emulation, I'm going to get it connected to a cable modem. There is one modem which earlier examples we have just seen how this emulation can get connected to a router that is in frame relay. Now we'll see how this WAN emulation or whatever it is can get connected to a cable modem, and how this modem will help us further, or what is the activity of this cable modem. We'll also see in this. Then from there, what we're going to do is we're going to take a home gateway. Probably this is a home gateway which is getting connected to the cable modem. So probably I'm trying to maintain one network here. I'm trying to maintain another network here, and then we're trying to maintain other network here. Right? This is, so there is a probably a home gateway which we're going to take it. To that home gateway, probably we may say there are a number of devices that got connected. Example, a IoT enabled fan, or it can be a light, or it can be something like motion detector, or it can be something like a window, or it can be something, what else we can take, maybe a door or a speaker, whatever it is, some IoT devices we are trying to get it connected. So let's get these devices connected. All right, let's get these devices connected. So we're gonna connect a cloud to, sorry, gonna connect, gonna take a serial 0, no, go to cloud. Okay, serial 1 is not available. Serial 2, no, and no, cable modem is not. Okay, let's using a coaxial cable or something we have connected it. It work by default or not. Okay. So let's connect this. All right. Then let's connect from central office server to the router to the, again, let's say network. We'll connect these two as a one network. So we'll take one switch. Let's take one switch. So let's take a generic switch, and we're trying to connect this generic switch to a generic switch to a router. So there's a physical connections which we have done. We have not done any configuration as of now. Right? We've just connected all the physical components and device. Now let's connect these people also. All right. So we're gonna connect using these devices have to get connected to this gateway. So for connecting gateway, let's say we're gonna keep some password. So I'm gonna go to the config and I'm gonna say wireless. The gateway is home gateway. Fine. It has to get connected using it. Now these are all uh, different authentication modules. You can either disable the authentication, all right, so that it is open for everyone to get connected, or it can be in a WP or WPP or WPA. There are different level of authentications, right? Simple or complex, more secure kind of. Right? Let's go with the WPA to authentication protocol, right? Or let's say it is a wireless protocol authentication, whatever it is. And we're going to say a password is to get connected to this gate. Home gateway is going to be password is 123, Vivek 123. And we're not changing any SSID. SSID, we're going to keep it as it is. If you wanted to change the SSID, you can do that also, as we have done in the yesterday's class. Okay. So now I'm going to tell this fan, it has to connect to the gateway, home gateway. So first, I'm going to enable for this fan, I'm going to enable the wireless device, wireless interface. So for that, we're going for the advanced. Then we have a physical, IO configuration. Then I'm going to change the network adapter mode to a wireless adapter. Earlier, it was a, let's say, let's say for Ethernet adapter. Now we're going to change that to a wireless mode, right? So that it gets connected. Now, as of now, it will not. Earlier case, it used to directly connect to the home gateway because that time there was no password, there was no authentication to be provided to the home gateway. So now, since we have set the authentication, it cannot by default connect. So what we need to do once we make it to the let's say wireless, once we enable the wireless adapter, then probably we'll go to the config. Then we'll say it has to connect to the home gateway. Right? It has to connect to the home gateway. Probably it should ask for the. Let me just give me a second. Home gateway. So, right. So in the interface, we're going to say password is going to be wait 123 for getting connected to the home gateway. Right? We're going to set it. Now, probably this time this guy will get connected. Yeah. So I'm going to repeat the same step for these devices so that these devices get connected to that. So first, what we're going to do, we're going to take the end device. We're going to go to the advanced mode, and then we'll enable the network adapter to a Wi-Fi, or it's a wireless network adapter. Then we'll come back to the config mode. In the wireless, you can see it is by default SSID, it is searching for the home gateway. Now, still it is not connected because it is secured. It has to be get connected. So we're going to keep the password so that it uses these credentials and it will get connected. All right, it will get connected. Yes. So quickly, I'm going to do it for these three devices also. We are just trying to connect the physical devices. We have not configured anything as of now. We are just trying to connect the physical devices. Now Now for the motion detector also, advanced physical or let's say IO, then enable the network adapter, wireless network adapter, then go to the config in the wireless mode, let it get connected to using the authentication. Get connected. Meanwhile, we'll do it quickly. The other one, wireless config and wireless has to connect to the home gateway. If you have changed the home gateway name, you have to update the home gateway here. Suppose if you have changed the home gateway name in the, let's say, at this location, then you have to change accordingly the SSID. As of now, we are going to keep it the default one. We're not going to change anything. Let the speaker also get connected. Wireless adapter. Let's go to the speaker. Also has got a Bluetooth mode. Connected to the wireless. 1, 2, 3. So now, at the first stage, we made all the end devices to get connected. We have not configured anything. We just made all the end devices get connected through using a default SSID, and we have used authentication, WPA, and then we made the devices to get connected. All right. Now, as a next step, what I'm going to do is, as I said, this we're going to consider it as a one network. This we're going to consider it as another network. And this we're going to consider it as a different network. So the IP addresses, what is the range I'm going to use it? Maybe I may ask the router to help me in configuring those IP addresses, let's say remotely or using a DHCP. So, but however, to understand for this network, what I'm going to do is I'm going to use 192.168.1.0 network. I'm going to consider it. So this I'm going to consider it as a 192.168. Let's say it as a 2.0 network. This I'm going to consider it as a 192.168 3.0 network. So these are the three networks I'm going to consider: 192.1.0, 2.0, and 3.0 subsequently in a circular manner over the Now, going further, what I'm going to fix it here is probably I'm going to, this router has got three gateways, right? Three interfaces. Now we need to assign the first stage, or let's say in the next stage, we'll assign the gateways. So for that, what I'm going to do here, I'm going to assign 1.1. Here, I'm going to assign 2.1. Here, I'm going to assign 3.1. So that is the first thing which we're going to take. Then, the remaining devices have to get the IP address by using a DHCP, which we are going to configure in the router. Even here, the remaining devices has to get the IP address using a DHCP, which we are going to configure it here. But for these devices, we're going to assign the manual. Right? We are not using any DHCP. But however, we are hosting a DNS and other things. Right? So for this, I'm going to take the DNS as a 2.1, 2.2. For IoT server, I'm going to take it as a 2.3. Let's configure that first. We'll configure these interfaces. Then we'll come back, configure these IP addresses. Then we'll go back here to the router and we'll enable the DHCP accordingly. The pool we're going to enable it. All right. So that I'm going for the router. I'm not using CLI mode. Let's go with the GUI mode so that we'll save some time. So fast Ethernet interface. So what is the IP address I wanted to assign for this fast Ethernet 0/0 interface? I'm going to assign 192.168.1.1. Right? This is the interface, let's say IP address which we're going to assign. And the subnet marks, let it standard default subnet marks. And I'm going to say port is on. Fine. Then we're going for this interface, probably 4/0. That is the interface. I'm going to say port is on. And I'm going to assign 2.1 here. This is also done. Then we're going for this interface 3/0, sorry, 1/0. I'm going to say port is on, and then I'm going to assign it as a 3.1. We have done. So we have done the first step. If you see the first step, we have connected all the end devices. Second step, we made IoT devices to get connected to the home gateway. There might be spelling mistakes, don't mind. Home gateway using wireless am I audible? Someone texted in the chat saying that the are not audible. Okay, now audible, Vishal. No problem, no problem. We'll edit this. So using a wireless network adapter, right, and authentication. So that is the second step we have done. And the third step we have done is for the router, we have assigned the gateways. This is the third step. Fourth step, what we're going to do is we're going to configure IP for DNS and IoT, probably the registration server, whatever it is, which we're going to take it as IoT registration server. Right, let's see that. And one more thing is, I'm going to rename the server for easy understanding. We'll say it is some ISP, probably we'll say FPT ISP. So this is one ISP router. Let's understand. So from this ISP, these devices are get connected because this window is routing the packets from this network to this network. So he acts as an ISP now. So let me go to the server. So first thing I'm gonna say to this server was your IP address is gonna be 2.2, and this is your subnet mask, and your gateway is gonna be 2.1, and you itself is the DNS. So your DNS server is also gonna be 2.2. Hope you understand the way I have assigned the IP addresses. Right? I said your IP address is 2.2 and your gateway is 2.1 and DNS is yourself. That is, say it as a DNS server or whatever it is. So this, after doing this, I'm going for the services and I'm going to enable the DNS service. I'm going to enable the DNS service. Right? That's what we have done. Right? So we have done with this aspect of the DNS. We'll do more configuration, but as of now, we have done the IP address. Similarly, for the IoT device, I want to say was your IP address is 2.3 and your gateway is also going to be 2.1 and your DNS is going to be 2.2 because DNS we have posted it in a 2.2. That's why we're going to say your DNS is going to be 2.2. That we set to this, and after telling this, we have to enable the, since we are using this server as a IoT server, we're going for the services. Now there is a service called IoT service, then we're going to enable it because it has to act as a registration server. So it has to register all the IoT components remotely which are available so that we can either control here or it can monitor also. We're going to say, since this is IoT server, we're going to maintain. So we said IoT devices or whatever it is, the registration server should be on. Right. So that we have done with respect to this. The fourth step we have done. Right. Now, going further, all right, we'll do a network by network. So this we have completed as of now. Then I'm going to jump to this network. Then I'll come back to this network. Right? So now in the central office server, what we're going to do is look at this. Now for the central office server, right? So if you see the So now this server has got a IP address by default. Some DHCP server generally it has got some IP address, but this is not the IP address which we wanted to have the DHCP range or whatever. It has to pull from the whatever the range we are using it. Right? So for that, I'm going for the backbone, and now we're gonna since okay we have not done any configuration, but we'll keep it in a DHCP mode and we'll do the DHCP enabled here, and then we'll come back and check whether the 1.0 network IP address has been assigned to the central office server or not. So as of now, if you see, the central office server has got some DHCP range. So this may assign using this range to the end devices here, to the cell tower or whatever the devices here. So that is one. So the central office server has got a service. One is DHCP service. Right? In DHCP service, this is a default which has been set, but we don't want this to be happen. We want this IP address to be assigned to the DHCP server. From there, it will pull the IP addresses to these fellows. So that information I have to tell here in the router, so that when I tell in the router saying that 1.0 is the network for this side, and when I enable a DHCP here, it should pull from the 1.0 network. So that's a reason we're going to see the backbone, right? Backbone in the sense the IP what will be available here. I'm going to keep it in DHCP, but it has not pulled the data details because we have not told it in the router about the DHCP profile. Right? We'll just keep it in the DHCP and we'll come back and check. Okay. Earlier it was in a static mode. Now we change it to the DHCP. Now what I'm going to do is now the next step is the fifth step. I'm going to config. We're going to config DHCP for 1.0 network and 2.0 network. Sorry, 3.0 network. So in the router, right? Probably FET ISP router, right? FET ISP. So at this place, we're going to configure two profiles. One profile of DHCP is for the 1.0 network. One profile of DHCP is for the 3.0 network. So let's do that quickly. I'm going to the CLI mode. All right. Exit. So I'm going to say now IP DHCP. All right. Exclude. First thing I'm going to say exclude from 1.0 network. Probably with the first 5 IP addresses, I'm going to exclude. So 192.168, 1.12, 192.168, 1. Probably 5. We're going to exclude it. So these IP addresses, we're going to exclude it. Then I'm going to say IP DHCP pool. This pool is for the probably the cell tower side. Pool for cell tower. All right. So we created the pool for the cell. We are creating the pool for the cell tower side, and we're going to say network 192.168. It is 1.0 network, and with the subnet mask of 255.255.255.0. All right. That is the network. And what is the default route? Default route for that 1.0 network is 192.168. It is 1.1 is the default route because we have assigned 1.1 here. So that is a default route for these people. So that is the default route. And what is a DNS server? DNS server for those people is 192.168. 2.1 because DNS server is posted here. So I wanted these people for everyone. The DNS server has to be assigned as a 2.1. So that we're going to tell it. Okay. So that is one pool we have created. All right. We have created one pool. Now similarly, we are going to create another pool for this home gateway. We're going to create another pool for this home gateway. Now for the home gateway also, as we have done for the central office server, we'll set it to the DHCP. All right. Let's say the internet. Okay, it is already in DHCP mode in Autoword. Now we're going to set the profile so that it will pull that IP address range here. Right? So we're going for the next profile. We're going to create IP DHCP exclude 192.168. Now this is for the this network which we are going to do it. We have the 3.0 network. For 3.0 network, it has to exclude 3.12. Some IP addresses we're going to reserve it. It is not that we have to exclude only 5 IP addresses. As a safe side, I'm going to do it 5. You can exclude 1 or you can exclude 2 or as many you want within the range. Right? As of now, we're going to reserve, let's say 5 IP addresses. Maybe I may use as one as a gateway, one I may use for other place as a static IP. So that's a reason. Right? We're going to exclude it. And then we're going to say IP DHCP pool. This pool is for the, let's say, home gateway site or WAN emulation site. We're going to say home gateway. Pool is home gateway, whatever it is. Right? So that is for the home gateway site. Then I'm going to say network is 192.168. We got 0 network with a subnet mask of 255.255.255.0. Right? Then just give me a second. Sorry for that. So network, this is a network I'm going to say. And then the default route we're going to fix. Default route for this network is going to be 192.168. 3.1 is the default route for all the ND wireless there. And then we're going to say DNS server as 192.168. 2.2. Even for this network also, we're going to fix this itself as a DNS server. All right. So, okay. We have done the pools. Now let's go to both the places. First the central server, then we'll say backbone. We'll just shift it to the DHCP and set it to DHCP. Now you can see this fellow has got from 1.7, right? And it has got as 1.1, and it has got DNS server as a 2.1. Oh, it should be 2.2, the DNS server. I think we have configured wrongly when we have done in the router. Alright, it should not be 2.1. Let's edit that. So did we do wrongly here? Somebody has pointed it. So we created for this router DHCP 1.1. We did it wrong here. So let's edit that. Alright. So we're gonna say DHCP pool cell tower. Right. Default route is gonna be 192. Sorry, DNS is gonna be 192.168 2.2. Let's see whether it has reflected or not. So we're gonna come back here, backbone. That not reflected. Not reflected. Okay, we'll do one thing. We're gonna say no IP, no IP. Sorry, we're gonna say the exclude we have done already. Let's see. DHCP exclude 192.168 1.12 192.168 1.5. Then we want to say IP DHCP No, DHCP folders, cell tower, right? We're gonna say network 192.168.0 network 5.2.0. Then we're gonna say default routers 192.168.1.1 is the default route, and DNS is 192.168.2.2 is the DNS. Let's see, hopefully it will work now. Ah, it is updated. Very good. So now you can see it has updated. So similarly, let's check with this guy whether the DHCP is updated. We're going to keep a DHCP on that, and he is not still getting anything. Okay, there is a slight update we have to do because this fellow is not able to pull the details of IP addresses DHCP because this has to send it here. There is a connectivity which we need to maintain in the cloud or WAN emulation, all right, DLCA, all those things. But let's do it simple way now. So I'm going to click the cloud. I have the interfaces in the config mode. There are interfaces. You can see serial 1, serial 2, serial 3, modem 1, 4, 4, 5. So first thing I'm going to keep it is I have an Ethernet cable here. Right? It has to act as a cable. That's what we're going to set it. Ethernet 6 has to act as a cable, not DSL. It has to act as a cable. Then I'm going to say to the coaxial 7, all right, we're going to say to the coaxial in the cable. Now coaxial 7 is getting connected to the Ethernet 6. Coaxial 7 has to connect to the Ethernet 6. That we're going to add it. All right. So that is a link which we made it here. Hopefully it should pull now. Yes. Now you can see it is 3.7 it took the home gateway. All right. 3.1 is the which we have assigned the default gateway it took from the router, and 2.2 is the DNS server. Okay. All right. So now what we are going to do next step is we have assigned as of now that, as I said, the fifth step, we have assigned the DHCP in the router, and we made these device and this gateway or whatever it is get the IP addresses from that particular DHCP range that we have done. Right? And let's check for these end devices also. The IP address is assigned accordingly. So we're going to keep it wireless. We're going to keep it from IP address also, just to pull that from that range. Okay. It is in the default one. Just to pull from that range. There is some modifications which we need to do because this fellow is getting the DHCP. Now the other people have to get the IP address. Full by default. In a minute, we will drop the config. DNS server it is able to pull, but the gateway gateway it is wrong. Let's see. Read that. Okay, that we have to do it first here. The home gateway, the DHCP, we are getting it here. The LAN settings and wireless. LAN settings has to 2.2 25.1. This fellow is taking 3.7, 3.1. The further it has to give accordingly. Yes. Let's say this again. 3.4. Overlaps with the internet. Okay. It's not allowing us to do the 3.4. Enable the DHCP. Well, let's see. Virus. Get. Okay. Yes. Take some default. Just give me a second. Now let's pull the other network. Let's keep it. Now we'll go to the DNS server. So now what we observed is this fellow I've got from DHCP pool. It has tried to pull that 1.0 network details, and this home gateway has tried to pull 3.0 network details from the router. We'll come back to this. Let's see if they're able to ping the DNS, that's fine. If not, then we'll come back and we'll try to change the 25.0 networks here. Usually it has to pull from this. Let's see. Any doubt as of now? Anyone wanted to say something? So now we're going to the DNS. For the DNS, we're going to assign the IP address that we have done earlier. Fine. Even for the IoT server, we have assigned the IP address. Fine. We have enabled the IoT services also here. All right. We have enabled, just give me a minute. So we have enabled the IoT services also, and HTTP also is by default it is enabled. Now, we'll go to the device, we'll go to the settings, or let's say in the config, we'll make sure it is connected to the remote server. Right? What is that remote server? Remote server is 192 remote IoT server. It is hosted at 192.168.2.3. It's hosted. By default, username and passwords will be admin. Admin. We'll say. All right. Once it gets connected, probably we should be able to see that device in this. We'll go to the browser, or we'll go to the IoT Monitor. So, registration server is hosted at 192.168.2.3. Admin and root. Sign up. Ask for sign up on the browser. We'll say 2.3. Admin. Admin. And which we said here, that should be get connected. Yes, the fan got connected in the IoT service. So what we did, we enabled the IoT services. Now you can even monitor from the IoT Monitor. So now you can see the fan has got connected. This fan has got connected or got registered in this. How it has got registered? Because he said the fan connect to a remote server, and where the remote server is existing, we have given the authentication and we have registered. So similarly, we will ask the light also connect to a remote server is posted at 2.3 and the password is admin. Connect. Probably in the remote server. Okay, the light also has got connected now. Let's tell the motion detector also to get connected in that way. So, remote server is available at 2.3 admin. The admin is the password. Get connected. That's it. Yes, the motion detector now got connected. The window. It's a window also. Remote server is available 2.3. Password is admin. Admin. Get connected. The speaker, you want to say remote server is available at this. Password is admin. Connected. Right. Now we'll add one more thing. We'll take a laptop for us for our reference. We'll connect the laptop also because we try to configure the remote server also remotely. So we'll tell this laptop your IP address has to be in DHCP mode. No, this laptop let's connect it in a wireless mode. Let's go to the physical. Change the adapter to a wireless adapter. Now it should get connected. Wireless adapter. Wireless SSID is home gateway. Let's give the home gateway SSID. This is the home gateway. So we're going to copy that as a SSID. And password is 0123 to get connected. Laptop to get connected. Yeah, in a wireless mode. And it should get the IP address also. Yeah, that's fine. Now from laptop, let's try to access the remote IoT server, that is 192.168.2.3, where hosted at remote server, and we are trying to log in. Now you can see this server, whatever hosted here, we are trying to access from the laptop, same services remotely. Right? So that is one. Okay, this works fine. As of now, we have got connected remotely all these devices. So we made them to get connected. Next step, what we're going to do is we'll go to the DNS service and we'll try to we'll go to the DNS service and we'll try to add a record here saying that www.vivek.com. Now this is going to map to my let's say our 2.3, sorry, 192.168 2.3, which is IoT server. If anybody pings using vivek.com, that will direct to the IoT server. That's what we're going to add it to the DNS. Now this DNS is updated to everyone. Example, in the browser here, if I access vivek.com, www. or let's say 190 vivek.com. Right? It should take me to this server. I'm going to give admin. You can see all the devices. What is happening is we use a DNS server so that instead of IP based, we access the server using a vivek.com anywhere here. That's how the DNS server is helping us now. Right? Now you can see instead of typing the IP, I went through the browser. Even in the IoT monitor here, right? When we have an IoT monitor, when it asks, let me say log out, when it asks for the IP address, even I can give the IP address as www.vivek.com now and the password admin and admin. So when I say connect, it connects. So now IP has been mapped to the DNS. Sorry, IP has been mapped to the name by using the DNS server. Okay. So now let's do this side, the smartphone side. Right. So let's go to the smartphone and we'll say first for this smartphone, the IP address has to be assigned by the central office server using a 3G and 4G cell mode. We're going to keep it if the phone is connected using a 3G and 4G cell. So let's see. Now I'm going to ask to get the IP address. So it has got some IP address and the DNS server. But let's see this side. We have given the static or let's say dynamic IP. Other cell. Okay. This is 172.168, 1.1, whatever it is. So from this, it is trying to pull as it has happened for these end devices. Let's not worry about it. So from the smartphone, we'll try to access service through the monitor. I want to access from the smartphone. So that www.gov and admin. Yeah. Now you can see from the smartphone also we are trying to able to access this IoT services. Now from the smartphone I can control the fan. You can see the fan in this network which is trying to access, but we are doing the access from the smartphone. Even light from the smartphone we are trying to on or dim. Even the motion detector, okay fine. Window we are trying to open and close. And speaker probably on and off, whatever it is. Even motion detector gets detected. Look at this. When I pass the cursor, you can see the motion detector is remotely monitored. So this is like something a small network, which or you say 3G or 4G or whatever you call it, a network, where you are trying to access all your end devices remotely using an IoT server somewhere and DNS and through a mobile phone. This is how you're gonna configure. And then from there, you can even go for the conditions. We have not written any conditions here. We can write the conditions also as we have done yesterday. A simple condition is, suppose, let's say, Windows should, or let's say IoT 3 device. Okay. Windows should be open, right? That is a condition we will write. When the IoT 3 device, or sorry, 2 device, that is motion detector, is on, when it sends on, then IoT 3 device, all right, has to be set to true, on. So this is a simple one condition we are trying to add to this. So whenever this is on, this has to be open, right? We added one. Let's check that happens or not. We'll check from the smartphone, all right, to a browser. Now we have a, where is that, window and motion. Now let me do a pass here. Now you can see when there is a pass here, window is open. Same thing is reflected here. Like this, you can write n number of conditions. Depends upon the end devices. What all the end devices depends upon the end devices. You can write n number of conditions there. So this is the first example which we wanted to do it for today. Maintaining a small network or 3G or whatever the mobile network, so that we can access all the IoT end devices. let's quickly finish the second example also, and then we'll close by 9:30. Right? So now, before I go to the second example, any doubts in this? Any doubts in this? How to connect these end devices and access these end devices remotely? And IoT devices. Any doubts? Someone? The text box, the chat box. I know it might be a bit confusing the first time. When I share the video or recording, you can practice that back at your home and try this. It says no. What about others? Krishna Teja, any doubt? Sriram, Krishna Teja and Sriram. Srinivas, any doubt? It's Srinivas. I hope they will reply it. All right. So let's go quickly. The second example. We'll take a simple example where we can write a small piece of code, a Python code. So it's basically try to introduce to you saying that yes, this way of configuration is also available with a packet tracer or let's say the network. So for the next example, it's a very simple example. Probably it will take hardly 5-10 minutes to complete. So what we're going to do is, all right. So now I want to take one LED indicator. I'm going to take one LED indicator, and then I'm going to take a single board, controller, computer, or whatever you call it. This is like an Arduino kit which we use in IoT devices. You have an MCU board also, the actual Arduino board also here. So now this is a single board computer. Then I'm going to take, let's say example, a switch. So now we're going to write a simple Python code to this board saying that when I press the switch, the LED has to glow. When I press the switch again, the LED has to off, whatever it is. Right? So now we'll connect these devices, but this time we're going to take a let's say a digital cable. We're going to take a digital cable to get connected. Probably let's say okay, the switch. So this board, you have a let's say USB port also to get connected. The end devices can get connected using a USB port also. This board has got let's say, look at this. This is a closer like board. It has got a power on or whatever it is, and then there is a module which you can add, and it has got let's say an adapter. This is how the physical board looks like. This is how the physical board looks like. So now we have taken a digital cable and connected this. Now I want whenever I switch on this, the light has to glow. Because that means the instruction has to go to this board. That means I have to write a piece of code here saying here in this board, when you get the input as a 1, the output has to be 1. When you get the input as a 0, the output has to be 0 in these interfaces. That you will write a piece of code. You can write a Java code. You can write a Python code. There are different languages where you can write that code. Right? So we're going to click on the board. Right? Then I'm going to click on the programming part. And if you see in the programming part, let's create a new programming environment. I'm going to click on new. I'm going to say this as a simple example, simple project. And there are different templates. You can see when you click on the template, you can write it in a Python, you can write it in a Visual Studio, you can write the code in the JavaScript, right? There are some predefined codes are also available, email or HTTP, whatever it is. And you can edit those codes. All right. So now, as of now, we're going to say it's a new Python code which we're going to write. Right? That's what we have selected the template. We have not taken any other broker or client situation. Let's not worry about that. The template, we have taken it as an empty new Python code, which we're going to write. So what code we're going to write it? Probably we'll write a code saying that when the input comes 1, the LED has to glow. When the input comes as a 0, accordingly, it has to glow and off, whatever. Okay, let's create that Python environment. So you can see there is a main.python which is created. Just double click on that so that you can write the piece of code here. Right? So the piece of code which we are going to write here is the first. I'm trying to import 2 packages. Probably the first package I may say GPIO package, or the input and IO package. Then I may use some delay command in this because how much time the light has to glow. So I'm going to import the delay package also. All right. So how do I import? Unlike in your C++, you used to say hash include or whatever it is. You're going to say from, all right, the GPIO. All right. So that is the library or a package or whatever you call it. I'm going to say import. Right? What it has to import? It has to import all the moment you say star, it means it has to import everything in that. So that one header file, or let's say one package we're going to import. Second is we're going to import maybe a time library. It has to import all. So that is the 2 we have imported. Right? Now, as you know, every programming language has got a main function. So we're going to define that. We're going to say define main, and we're going to write some code. What is that code I'm going to write? I'm going to say we're going to call it as a pin. Each interface, we're going to call them it as a pins, whatever it is. I'm going to say pin mode. I'm going to say pin mode. This is 4. This is the 4th, or let's say digital interface 4. I'm going to say 4, right? We're going to set it for the input. So we made 4 interface as an input, and we're going to say pin mode. The 0 port or 0 interface. This is 0 as a out. All right. So this we have set. Then we're going to write a small if condition. We're going to use a command, built-in command called digital read. Right? That will help us reading the input for that ports. What is that command? Digital read. Digital read. I'm going to read the port 4. Right? We said if the digital read is equal to high. Right? So if the digital read is equal to high, we're going to say digital write. Digital write to the port number 0 should be high. All right. So that means when you press a on button, that goes as a high. When this is high, the output here it should be high, so that this will glow. When you off this, the input is going to be low. When this is low, that means the signal is going to send here as a low. That's what we are trying to basically write it here. So then we're going to say else. What is that has to be? Digital. The other side, other condition. Right. All right. 0 should be low. In the other case, the digital write should be low. So this is a simple logic we have written. All right. Then let's close this. Close the main. This is how we close the main in the Python. Name, all right, equal to sorry. in the double quotes, main, we're going to keep it in double quotes, and we're going to say that is the main. So this is a simple piece of code we have written. So let's see how it works, how it runs. So we're going to run this. There is an error, the line number. Let's
Check it out. Sir?
Yeah. Someone wanted to point something.
Yes, sir. So the pin mode and the digital read write, are they predefined? Or do you have to define them?
So we have to define this high and low you are talking about.
Yes, sir. No, the variables, the pin mode and digital read write.
No, it is predefined.
Sir?
It is predefined.
Okay, sir. Thank you.
So now this runs fine. This code. But what happens is when we run this, look at this. It has run and it has finished also in the backend. That means this code is able to execute one time and it is coming out. So we don't have a time to go back here and do something. So we are going to keep this in a iterative loop. We use a simple, let's say, looping while true. All right. We're going to keep this in a simple looping while true. Let's see, we'll run this. Now you can see it is not stopped because it is going infinite number of times. Earlier case, it has got stopped. Now let's go back here and switch on. You can see. Because that we have given input high. When it is high, the LED has to glow. When it is input is low, the LED has to switch off. That's how we write a simple, let's say, a Python code. Now it depends upon again end devices. You can explore or you can change the codes accordingly. Right? So you can explore these packages. What are the predefined commands are available for them. So basically, I'm just trying to introduce you saying that you can write a piece of Python code or Java code to configure the IoT devices. So that flexibility is also available with the packages. So if you wanted to add a delay, probably every iteration you can add a delay also using a delay keyword. You have a built-in delay keyword. So let's say delay, maybe some 100 milliseconds or microseconds, whatever it is. You can add this delay also, right? So let me stop this and run it. Delay is giving me an error. In Python, even space and tab also. All right, we added a delay also. All right. So let's see. Yes, it's fine. Every iteration there's a delay also added. That you can do. Even the end device can be a fan also. Now you can click the input goes. It can be another light also. Basically, it depends on what interfaces you are trying to use it here. Right. So that's it from my side, probably for today's session. So as part of your 8th unit, we try to do 4 different types of simulations and to understand the case studies or let's say the possible options, all right, with the in the network. Right. If you have any doubts, probably you can ask me now. If you have any doubts, you can ask me. Because with this session, we will be closing the 8th unit. And I will be giving some different scenarios also as a part of project for your 8th unit, where I may ask you to configure so-and-so simulation as a batch wise. You need to configure that and you need to send me across. So that batches also I'm going to make it 1 to 5 or let's say 5 to 10. I'm going to make some 10 batches. For each batch, I'm going to give you a similar kind of an assignment kind of thing. Probably your 6th or 7th assignment is going to be on the 8th unit. All right. So when that assignment comes, I'm going to give it as a batch assignment. And for each batch, I'm going to give a task, what you need to configure, what is expected. And then you have to configure these devices accordingly, and you have to submit that as a project, the simulation itself. So that is my objective with respect to the 8th unit. All right. Now you can ask me any doubts, whatever if you have. So I'll be happy to take the doubts. Then we will close the session after the doubts. No doubts? Nobody is texting in the chat box? No doubts in, okay. No doubts in the sense that I should be happy that whatever I explained, you people have understood it. I should also, maybe it may concern other way also. Nothing is understood, then no doubt again. If there is no further doubts, probably we'll end the session for today. Okay. So before you leave the session, make sure you have dropped a hello message in the chat box so that your attendance is recorded for me. So try to explore more topologies. You create your own topology and try to configure accessing remotely these IoT devices, creating a small IoT projects kind of thing. You can do it in this, right, in a packet tracer. So try to explore I have given a limited exploration of different end devices. You try to explore more end devices, and always there is a CISCO portal where if you have any queries, there is a forum available. Even I am available. You can ask me queries anytime with respect to this. Right. So there are some, let's say, you try to create your own project kind of thing out of this, which will help you. So what happens is, the best part is, see, if you buy a home gateway and if you configure wrongly, it might end up in crashing. Or if you buy a SBC board or other board, it might end up in let's say burning. So best thing is you can do the simulation completely here. Once it is ready, you can then just copy and paste that piece of code into your physical boards. So that's a benefit, or let's say you can even completely test your environment also before you get into the physical components. You can test your environment also here. So that is more added value. It will save a lot of let's say malfunctioning of the boards or other things. Right. So that's it from my side. So thank you for participating for today's session. Hope you found it interesting. Right. We'll meet in the Monday's class with a new topic. Thank you.